All right, practice problem number 5, last one. All right, so this is going to be another Stoic problem that we'll work our way through. And this is one that isn't going to be at STP, so we got to do something a little bit different, which is kind of going to be a combination of what we just did on the last two problems. So if we have 28 grams of aluminum and it's corroded with hydrochloric acid to release hydrogen gas, all right, if the reaction takes place at 25 degrees Celsius and 812 millimeters mercury, what volume of hydrogen will be produced? All right, and so the idea is you have to understand we're not at STP. So even if we're looking for volume, or really we could be looking technically for anything else, um, we can't go any further. We can't use that 22.4. All right. So the first thing we have to look at is having a balanced chemical equation. So it says aluminum metal is corroded with hydrochloric acid, and it's going to make us hydrogen gas. We got to remember that's H2. And then what we also got to remember is, all right, there must be something else. And so that's going to be AlCl3. All right. So as we go through this, we got to balance it. That is going to have to be a 3, right? But then that would have to be a 3. So that's going to make it a 6. So we got to go a 3, a 2, a 2, and a 6. And this works out because there's nothing, right? The 2, the 6, and the 2, those would all be divisible by the same thing, but not the 3. So that works out. Okay. So our next step is, what do we have? All right. So we have 28.0 grams of aluminum, right? And what we want to know is how much hydrogen we're going to produce. So we go down, we'll go over, and we want to be able to go up. But the only way we can go up to get to liters is if we're at STP. And we're not, so we can't do that. So basically, we're going to stop right here, and I'll show you what we're going to do. All right, so we're going to do our stoichiometry. So we have 28.0 grams of aluminum. All right, and then we're going to do our first step, and we're going to say, all right, well, 1 mole of aluminum is equal to 27.0 grams of aluminum. All right, so grams of aluminum cancel. There we go. We're going to do our mole to mole step, and so we have 2 moles of aluminum, and on top we have 3 moles of hydrogen gas. We have to stop right there because we can't use the only other ratio we have to get to liters is if we're at STP and use the 22.4. So right now we're going to finish, and what we finish with is, so we have 28 divided by 27 times 3 divided by 2. And so we have 1.56 moles of H2. Now, if we look at it, we have moles of H2, we have a temperature, we have a pressure, right? And we want to find the volume. So what this problem turns into at this point is it turns into an ideal gas law problem, right? And so we're going to write out those parts and pieces. So I have N, which is 1.56 moles of H2, right? I have a T, which you can't see, but it's 25 degrees Celsius. But I got to add 273 to that, right? And so I end up with 298, right, which is a typical room temperature of Kelvin. I have a pressure, again, you can't see it, but we scroll back up there, we can. It is at 812 millimeters mercury, okay? And then all we have to do, if we want to find V, we need our R because we know our V is our unknown. We need a certain number of liters. And so when we look at our R, knowing it's millimeters of mercury, we're going to use a different number. This is 62.4, and this is liters times millimeters mercury over moles. Okay, all right, so we have everything right there. So we take a look at our PV equals nRT. PV equals nRT. We solve for V, so we have nRT over P. All right, and now we can just plug in those numbers. We have 1.56 moles, right, times my R, which is 62.4. Okay, I'm going to forego writing all those in. We know they work out at this point. And my temperature is 298 Kelvin, right? Divided by my pressure, which is 812 millimeters mercury, right? So the millimeters mercury, these are all going to cancel based on those units that we have over here. So the only thing that's going to be left is going to be our units of liters, which is good because we're finding a volume. So again, at this point, pretty straightforward. Multiply and divide. So 1.56 times 62.4 times 298 divided by 812. And we come up with an answer of 35.7 liters, okay, of H2. Okay, so this is how we can put stoichiometry and the ideal gas law together. We can use the ideal gas law at any time, right? But in problem number 4, sometimes it's simpler for an STP just to put in that 22.4. Either way, there's that last practice problem. See you later.